Here we have a nice particle velocity acceleration type problem. Got the calculator on this one. Please make sure you're practicing the calculator work with me and you're practicing that on your own so you're getting quicker with it and you're getting more comfortable with it and you don't have to think twice about it. You just know how it operates. All right, so we got this particle and they give us the velocity function. Make sure, see, I already typed it into the calculator and make sure you remember to enter in that minus 0.2t there. So like this, their whole velocity function. So I got that in my calculator. That's kind of like what the graph looks like right there. And then it says for part A, there is one time in the interval. So we're going to find this T sub R in between 0 and 2 where the particle is at rest. So it's not moving. And we want to find that time. All right, so let's start with that. And then there's another part of that that we're going to need to make sure we read there. So for part A, here's all my working answers if you just wanted to check a certain part. But if it's at rest, that means the velocity, that given function, is equal to 0. So it does say in between 0 and 2. So I just want to remind you, we can kind of see it's going to be at that point right there where it hits 0, where it hits the x-axis there. But if you wanted to, you could hit your window button and make your x-min 0 and your x-max 2, and then graph it. And then that's what it's telling us. It says there's only one spot where it's equal to 0. So if I hit my trace button and just move the cursor over in that vicinity, and remember, we'll hit second trace, and we want to hit that calculate menu. We go to number 2 where it says 0. We just want to move it to the left a little bit. So on a decreasing function, we're going to make sure those y's are positive. Hit enter. So it's to the left of that x-intercept a little bit. So hit enter there. And then it says right bound. So I got to move it to the right and then pay attention to the signs of that y value. Make sure it goes on the other side of the x-axis there. Make sure it goes negative right there. So once I see the y's are switching sign, I'm going to hit enter. And then for a guess, I usually just hit enter a third time. And I'm getting this 1.426 number if we round that to 3 decimal places right there. So please practice that on your own. Set the velocity equal to 0. Let it calculate that 0 for you. That's the first part. We found that T sub R. And then the second part says, okay, in between 0 and that number, is the particle moving to the right or to the left? So we know if we're just moving along the x-axis, it's going to be going to the right. That's the positive direction. So if we're going to the right, that means the velocity is going to be positive because velocity is that first derivative, right? And if we're going to the left, that means we're going in the negative direction. The velocity is going to be negative. So notice we have the graph right here in between 0 and that 4.26. That's all of this region. Well, let me hit the trace button. It's all of this region right here in between 0 and that 1.426. So notice this velocity graph is above the x-axis. And so since the velocity is positive, that means the particle is moving to the right along that x-axis right there. So you got to stress moving to the right since the velocity is positive. And I'm looking at where that graph is above the x-axis there. So, but you got to stress moving to the right and that velocity is positive. All right, so a couple parts for part A. And then the rest of this, I think, is going to go pretty smooth for us. It says find the acceleration. So you remember the order goes position, velocity, acceleration. So if I want to find the acceleration, I want to find the derivative of this function at that t equals 1.5. That's the math 8 function. The calculator will do that for us. Notice that that's my y1, so I already have this saved in my calculator. So this is going to be a nice, fun, quick problem there. So I want to take the derivative of this at this. So I said the acceleration at 1.5 is the derivative of my velocity at 1.5, and that's the math 8 function. So if I hit math 8, type that in, I already have that velocity function stored in my calculator. So I'll hit alpha trace, and that is my y1. That's the only one I have entered in. So there's my velocity function. And so it's going to take the derivative of the velocity function for us at this 1.5 number. And so you just need to mention, hey, the acceleration is v prime of 1.5, and that's your setup. And then they know you're plugging that into the calculator. So they would have accepted negative 0.999. And I just round that to negative 1.0. So that's just negative 1. You could also just have negative 1 there. So that's the first part. It says find the acceleration. And then it asks, is the speed of the particle increasing or decreasing at that time period? And so remember from our blue packet there, There's your position, velocity, acceleration. We know speed is increasing if velocity and acceleration have the same sign. Speed is decreasing if velocity, acceleration have opposite signs. So we already know the acceleration is negative. And on my graph, I'm going to hit my trace button. I can just type in 1.5 level. That is my velocity function. So you can either take the 1.5 and plug it in for all the t's, or since you already have it in your calculator, just hit the trace button and type in 1.5, and that negative 0.077, that's what the velocity is equal to at that time. So anytime they're talking about the speed increasing or decreasing, make sure you have what the acceleration and the normal velocity are equal to. And since they are the same sign, that means the speed is going to be increasing. So you just got to stress that. So you showed the work, speed is increasing at that t equals 1.5, since the velocity and acceleration have the same sign. But that calculator, please practice that. That's going to be a friend of ours. All right, so letter C gives us the position. Let's see, the position of the particle at time t is x at t, and its position at time t equals 1 is equal to that. So they're giving us where we're at t equals 1, and we want to find the position at t equals 4. So if I want to find the position at 4, I'm going to start with the initial one that they gave us. That's where I'm at t equals 1. And then so if I know where I'm at time t equals 1, I'm going to pick it up where I left off and integrate it to where I need to go. And so we know we're supposed to integrate here because anytime you go from velocity to position, you got to integrate that thing. So if you integrate the velocity, that just tells you how far you went. And then you're taking into account the initial position. So always take into account that initial position there. So again, if I want the time position at 4, I'm going to start with the initial, what they gave us. And since I already know where I'm at t equals 1, I'm going to integrate. I'm going to pick it up where I left off and then integrate it to where I want to go. Integrate it from 1 to 4. And this is already in the calculator. You're going to math 9 this thing. So they told us x of 1 was the negative 3. And so when I plug this into the calculator, I'm going to type in negative 3 plus, and I'm going to do math 9, the integral between 1 and 4. And I don't have to type that all in there. That's already saved in my calculator. That is my y1. So hit alpha trace, hit your y1, and it does that calculation for us. So they're going to want to see the setup always. So show the setup. We got that down. And then that's how I'm getting that negative 2.803 number right there. So letter C is done. And then the last part, it says total distance traveled. So in your blue packets there, your displacement, there's your total distance travel. So total distance travel, we got to remember, is the integral of the absolute value of velocity. So they want to see this. They want to see that. And it tells us between 1 and 4. So you're just going to integrate the absolute value of velocity between 1 and 4. If you wanted to, you could write down like that whole entire thing, but you could just write it like that for shorthand. And then again, we could do this one in the calculator real quick. And we're gonna be done with this guy. So I'm gonna hit math 9, go between 1 and 4, and then I'm gonna hit my math button, go over to the right, the NUM. The very first one is the absolute value bars. And then I could type in alpha trace again. That'll access the y1 velocity equation I have in there. And then it does that for us there. So just show the setup for your integral. Took a little second on that one, but that's how I'm getting that 0.958. And again, it's to your benefit to show the setups because they want to see those typically. And if you happen to bump something in the calculator wrong, that you're going to get credit for that there. So please make sure you're practicing the calculator work on your own and getting comfortable with that. And let me know if you have any questions with why I did anything or how we set anything up. And then make sure you group together a few of these velocity acceleration problems, group together a few of them together and kind of study those back to back to back. And that'll make you feel pretty comfortable with those because it's a very standard topic with this AB stuff there. And so practice that calculator, position velocity acceleration there. Mariner.